We're very serious about it. Our people are very psyched with it.
It will continue to coerce us and drive us and propel us towards manufacturing excellence.
We look at it as a journey.
You're totally changing the way you think.
A lot of people don't like change.
We're a part way down the path. We got a long way to go, and we have a part of the way that we're very proud of.
The word is out, and the word is spreading. Something new is happening in manufacturing. It's called just-in-time, and it's a revolutionary new idea that American manufacturers are beginning to take very seriously. Worldwide competition is fierce. U.S. manufacturers are fighting for their survival. Experts are calling it a desperate situation. Today, manufacturers are beginning to realize that to be competitive, they must change the way they do things. This program is about that.
Typical American electronics company, you'll see 3 turns, or in some cases...
Gary Flack was for many years manufacturing manager of Hewlett-Packard's Greeley, Colorado division. While at Greeley, he directed the installation of the division's first just-in-time pilot operations. He talks about the challenge ahead.
What do you suppose the Japanese think about American manufacturing? It's a very primitive form of manufacturing that we use. And they typically beat us by 10 to 1 in a lot of key measurement factors. Now, a lot of people find that hard to believe. They'll say, well, I could accept the fact that Japan may be 20% better or 40% better, but not 10 to 1. Don't tell me stuff like that because I don't believe it. So there must be an answer to this. The answer is we need to start learning how to manufacture.
If we don't do something, orders can dry up very, very quickly.
Bill Sandris is an independent manufacturing consultant with worldwide experience. While working at 5 different Hewlett-Packard divisions, he was responsible for 4 MRP and 3 just-in-time installations. Currently consulting for Tektronix Corporation, Vancouver, Washington, Bill talks to line workers about how the rules of the manufacturing game have changed.
Part of it also is that you know, there's the slogan that says... After the war, after World War II, we could have sold anything that we made. And in fact, we did, no matter how shoddy the quality was. Well, during the last number of years, the competition has caught up with us. And we can no longer afford to exist with the waste that we have in our systems today. We need to remember that we can no longer become complacent again. We cannot let ourselves settle on a manufacturing plateau while the competition around us is becoming more and more competitive.
Gary Flack explains the just-in-time system and how it differs from today's typical manufacturing mentality.
The whole concept of just-in-time is to bringing the material in just as you need it, instead of bringing it in 3 or 4 months in advance and letting it sit there and age. You bring your direct labor operations into play on this material just at the right time that you need it in the operation, and not under the American batch system. The typical way that we have built in the past in the American batch system has been just in case. So we bring everything in just in case we need it. First, we bring it in from several different suppliers just in case one of our suppliers goes down. Then we bring in a big batch just in case we don't have enough to go to the line. Then we bring it out on the lines, and then we have just in case stocks at various points. Again, trying to cover the fact that we may have some kind of an assembly quality problem later on. And so all the way through our system we have the just in case mentality. In a typical American batch system or push system, we have what's called a find and fix mentality. We build as much as we possibly can, then we go in and search for these problems, and then we fix them, and then we try to ship them to our customers. This system is very inefficient because you continually raise your cost as you're inspecting your parts. Under the just-in-time system, you're exposing your quality problems immediately, and therefore you're reducing your cost.
Above all, just-in-time is based on the belief that you must eliminate waste, specifically all activities that do not add direct value to the finished product. Just in time also means enforced problem solving. It uncovers quality problems and brings them to the forefront. Then just in time works hand in hand with total quality control to solve those problems. Together, they allow you to continually improve quality and productivity. Just in time means better use of resources, better use of floor space, more efficient line configurations, closer vendor relationships, and greater involvement of everyone from management to direct labor. These are the general principles of just in time. But what does it take to get there?
Before on our lines, we had all of our quality problems masked because we had a work order quantity for 150 units. And the worker would be working on 150 units. And if they had 6 bad ones, they'd put those 6 aside, and then they would call for a production engineer or someone to help them with this problem. The production engineer may not show up for 3 days. He may not show up for a week. He may never show up. And so what we were doing is we talked about improving our quality, but yet we were hiding our quality by pushing these units over to the side. Now we're building one at a time, and one bad assembly coming down that line stops the line. The flashing red light goes on, put on by the direct labor person, and now the manufacturing management has to come out and help solve this problem. And now your quality problems are visible.
An analogy that's frequently used with just-in-time involves water and rocks in a lake. Water represents inventory and the rocks represent problems. What we are to do is to drain the inventory until we expose a rock representing a problem, and then we are to fix the problem and eliminate it, drain the inventory some more or drain the water some more until another rock appears, and then fix that problem. And we continually and relentlessly drain the water and fix the problems until they're all gone. In the past, we've allowed ourselves to protect ourselves and insulate ourselves from the problems with inventory. We felt that inventory was necessary. There's nothing that says we can't change the process.
Converting to just-in-time means moving toward a pull system, building one unit at a time. Gary Flack tells how the change was made at HP Greeley Division.
This is the plant where we started just in time in November of 1982. Before this time, we were a typical American plant using the American batch system or the push system. Basically, it was a push system where you take your material and try to push it through the plant. And between each assembly and sub-assembly, you have big batches of material sitting there. Just-in-time system is a system where everything is tied together and you're pulling through one unit at a time. So you're building just what is required and you don't build any extra inventory.
A technique called Kanban makes the pull system work.
Kanban means is a Japanese word, and when you convert it into English it means visible record. Now really it doesn't have to be a visible record. What it is it's a communication signal. And a telephone call can be a Kanban, or you can say, bring me more material. That's another way of a Kanban.
Vancouver, Washington. On this assembly line, empty spaces on a Lazy Susan act as the Kanban, or communication signal, that another part is needed. It's a technique that pulls parts onto the line one at a time, only when they're ready for use. But how do you achieve a pull system? You reduce inventories and create smaller lot sizes. But how is that done? By reducing setup times, as Gary Flack explains.
If you have a very long setup that may run 4 to 8 hours, you'll find that you need to run 800 or 1,000 parts to justify this 4 to 8 hours. If you can reduce your setup time down to a single minute, you'll find instead of having to run 400 or 800, you can be down to 4 or 8. Or finally, achieving the ultimate of a lot size of 1. In our previous just-in-case system, we had a work order quantity of from 50 to 100 units, and we built those in a large batch. Now what you can see is Jeanette is building these parts one at a time. Well, how do we build one at a time? We use the single-minute exchange of die. Now when she's ready to load that board, she automatically scans it through the barcode. And this sets the parts that are going to be loaded on this one board. The next board will be different parts than what the parts that are going into this board. So this is a good example of how you cut your setup time down so you can load one board at a time.
And there are other ways to reduce setup times.
This is our radial lead insertion machine. The operation is fairly complex, and setup time plays a significant part of the overall run time. What we have done is to have dedicated cartridges, and each cartridge have been pre-adjusted to the particular component. This is our IC insertion machine, and again, to reduce setup time, we have gone to dedicated cartridges with preset adjustments. This has enabled us to reduce setup by approximately 60%, as well as to improve the overall insertion accuracy.
Reducing setup times is one way of eliminating waste. Sandris and Flack discuss other ways to eliminate procedures that don't add value to the finished product.
Some of the changes we have to make are the elimination of inspection, the elimination of storage, and the elimination of counting. Because all of these activities don't add any value to the product. The only reason that you do this is so you can charge a higher selling price to your customer.
If I inspect material 5 different times, it adds only cost, no value. If I put 499 extra parts in inventory for a year, that obviously adds cost and no value. The only thing that adds value is the processing itself.
The role of the inspection in the typical American factory is to try to inspect the quality in. So when you get the parts from your supplier, you try to inspect the quality in. Guess what? When you inspect the part, does that improve the quality? No. If you inspect the part 10 times, does that make the part better? No, it doesn't make it better. In fact, it slightly decreases the quality, because when you're handling it this many times, the quality level is going to go down. That's why inspectors do not increase the quality of your product. This has to do with the mentality we have, which is based on finding it and fixing it rather than doing it right the first time.
Inventory reduction, the pull system, reduced setup times, elimination of inspection. These techniques have been applied successfully. They do work. And the bottom line is this: when put in place, these just-in-time techniques add up to dramatic cost savings throughout your operation. But what are the real benefits of using just-in-time? There are many, but one of the most visible is a reduction in work-in-process and cycle times.
Most American companies going into just-in-time have a typical reduction in their WIP inventories of between 85 to 95%. Now, the reason this is so drastically reduced is because if you look at a typical factory, you'll find the work in process has all kinds of batches all over the floor. If you're moving the material through one at a time, you will have a 20 to 1 or at least a 10 to 1 drop in the work in process that's actually out on your floor, which leads to great space savings, great inventory savings, and of course now the cycle time is down to 1 or 2 days instead of 20 or 25 days.
Let's look at what a few electronics manufacturers have achieved with just-in-time. Tektronix, Vancouver, Washington. A measurement instruments and signal acquisition device manufacturer. In the last few years, they have been working hard to make just-in-time a reality.
Several years ago, we as an electronic manufacturer were fairly typical of most of the electronic manufacturers around the country. We had large inventories, we had long cycle times. In many cases, our cycle times of our products were greater than 60 days. We had many stocking points that went on in the manufacturing area and in our stock area. We had a lot of work orders that tended to push our products through our operations. and we tended to have a lot of rework because of the long cycle times and the problems that we encountered as we didn't detect our problems right away. Today our situation's a little different, and I think we made significant progress towards going into a just-in-time manufacturing operation. Today our cycle times typically are in days, 2, 3, 4 days. We have very little inventory. In fact, our inventory has come down approximately 70% in the last 2 years. We're using much less space. We're a work orderless system. We don't use work orders to drive our system anymore.
Colorado Manufacturing Technology, Colorado Springs, Colorado. A low-level assembly subcontractor, CMT is not only a just-in-time supplier, but a just-in-time manufacturer as well. They moved into just-in-time simultaneously with Hewlett-Packard, their customer.
When we started CMT, we grew very, very fast. We were working under pretty much the old philosophy of massive inventories, large orders, and up through 1982. When we entered into 1983, we were about a $10 million a year company, and making all the mistakes of any company with respect to production inefficiencies, high inventories, high overhead rates, and again, very fast growth. We were located in 7 different facilities throughout the Colorado Springs area, and suddenly realized that we were in possible trouble, and we had an opportunity to enter into JIT relationships with 2 of our main customers, Digital Equipment and Hewlett-Packard Greeley Division. We learned very fast from the Hewlett-Packard Greeley Division, working with them through 1983. As we progressed in 1983, our shipping dollars started increasing. We actually doubled our shipping dollars. We started reducing our facilities as a result of JIT. We reduced our inventory, and most effectively, we became more efficient.
Tektronix and CMT provide a sharp contrast between a low-volume, complex operation and a high-volume, standardized manufacturing process. Bill Sandris explains how just-in-time can be applied in any manufacturing environment.
Almost all of the literature available today that talks about just-in-time describes relatively high volume, low option, standardized product assembly lines. Just-in-time lends itself well to these processes. However, it also lends itself equally well to job shop manufacturing. Obviously, the exact implementation details between a repetitive manufacturer and a job shop manufacturer will not be the same, but the concepts are the same, to continually and relentlessly eliminate waste.
We began our implementation of JIT on the 2400 line approximately a year ago. At that time, we looked at JIT as a way of eliminating several problems we were having. One, we thought that through the implementation of JIT, we could better meet our customer commitments. And the other was we believed we could significantly reduce the work in process. An added benefit that we thought we might have would be the reduction in floor space. To date, we can report that we have achieved all those goals plus quite a few others. In the area of floor space, we have moved from approximately 15,000 square feet to 7,000 square feet today. We believe that we can reduce that further. As far as customer commitments, when we started this program, we were unable to make 14 to 15-week delivery promises to our customers. Today, we can make 2-week promises, and in many cases, we can deliver from stock. Cycle times on the product line used to be in the area of 30 to 40 days. Today, cycle time is 12 days, and we can build to order within 4 days. We were able to reduce work in process by more than 50%, and we're continuing to drive that number down, and we eventually will work into a one-for-one build. We look at JIT as an elimination of waste, and also we look at it as a journey. And from that standpoint, we feel that we're pretty well on our way, but we have a long ways to go and a lot of areas that we need to improve, but we feel very positive about the program and believe that we have significant benefits to gain in the future.
A key to making just-in-time work is the use of total quality control. Just-in-time exposes quality problems. TQC solves them. Together they are a powerful tool.
On one side of a coin is just in time, and by using a technique called Kanban to lower the inventories, we expose problems. When a problem is exposed, the other side of the coin is used, and this is total quality control. And we use this process to drive to the root cause of the problem to permanently eliminate it.
Total quality control is a program basically that has a number of elements in it. One of them is statistical quality control that we're taught how to do by Dr. Deming and Dr. Duran. They published many articles and books on this in the 1950s. A lot of people in the United States did not listen to them. The Japanese did. I think we can see a lot of results of this. There are many things about total quality control that the Japanese now understand, that it's a very massive thing. It means the total elimination of waste. Just continuing to improve your system through statistical methods, through analyzing your biggest Pareto, which is your biggest problem, in a very disciplined manner, continuing to go after your top ranked problem and eliminating that one, and then the next one that comes to the top, you go after it and eliminate that one.
Getting just-in-time and TQC to work internally is the first step. Establishing a new cooperative relationship with vendors is the next. It starts with clearly educating your vendors to your requirements. Establishing a standard for defect-free parts that require no incoming inspection, with frequent deliveries directly to the line. Assuring vendor part quality by working with the vendor from design through manufacturing. Tektronix works closely with their vendors at the vendor's manufacturing site.
I work in the incoming quality control organization, and we organized the group 6 months ago to support the JIT manufacturing process. We have a single engineer assigned to a single product line. That engineer works as a team member with the people in the group or product group to identify vendor problems and get this information back to the vendors to try to get the problems corrected as early as possible. The next step is that we work with the vendor to get him to work with the IQC engineering group to try to produce parts that are fit for use. Some of the results we've gotten have been very impressive. In the last 4 months, we've had 117 resolutions from vendors.
HP recognized the need to involve their vendors in their just-in-time operation. Gary Flack provides a specific illustration.
Okay, here's a good example of just-in-time. We have one dock space permanently dedicated to one vendor's part number coming in through this space. This part number is the foam molding that goes around our 5 1/4 inch Winchester disk drive, which is very susceptible to shock damage. We have 2 of these that go into one of these boxes here. This material comes directly off the truck and goes out on the production line and is immediately used. Before, we would have had a major part of our building just holding or storing this kind of foam molding material. Now, when the person unloading the truck gets down to 2 hours worth in the truck, then they call Kellum, which is our freight forwarder 5 miles away. That's the Kanban to them to send another truck to us. Then they in turn call Colorado Springs and say, build another truck of foam for these guys. That's the Kanban to them to get this next
truck moving.
One of our suppliers brings the parts in every morning in his truck, and on the side of his truck he's got JIT carrier, and he delivers those parts which he's made yesterday directly through our receiving department out onto the manufacturing floor and right onto the line. And the first time one of our direct labor people picks up this part is when they turn in their production position and reach for the part. There's no incoming inspection on these parts, and they're delivered directly to the line by our supplier.
If JIT requires no inspection of incoming parts, it follows naturally that standards like acceptable quality levels, or AQLs, must be eliminated. The use of the AQLs is an admission that a company is willing to accept and produce defective products.
One of the big changes that we have needed to make in American manufacturing is a point that Dr. Deming frequently points out to us, that we cannot use AQLs, or acceptable quality levels, on our incoming material or material as we process it through the plant. Typically the way an American plant operates under the just-in-case or the poor quality method is to take the lot and to measure the sample through an AQL method. As Dr. Deming says, this is a thing that relates back to our very primitive or caveman past. An American company was just buying from a Japanese company who he hadn't had a chance to work with before. And so he specified, as an American company would, an AQL level of 1%. So the first shipment of parts he got in from the Japanese supplier consisted of two boxes, one very big box and one very small box, and he wondered, why do I have two boxes? So he opened the big box and there was his parts, and he said, well, that makes sense. And then he opened the small box and he had a note in there, we do not understand why you want 1% bad parts, but here they are.
Better incoming parts is one benefit. There are others.
A real sense of urgency is another result that you get from a just-in-time type environment. In dealing with your vendors know that you really need the parts that you're obtaining from them, rather than going into your stock and sitting there for months. And on our lines and those that we deal with, they do know that it's a sense of urgency too in terms of resolving problems. We had a problem a number of months ago where we were dealing with one of our vendors in Germany. We had the line shut down and we had the line back up in 4 days through some real urgent efforts on the part of our people and our vendors.
Under just-in-time vendor cooperation is the key. Single sourcing is the best way to ensure it.
Today, when we have thousands of parts and hundreds of vendors, it is difficult enough to understand the incoming material quality for one part, much less understand the root cause of the problems from that part from 3 different suppliers. One may have a problem on delivery, one may have an internal quality problem. As we move towards single sourcing, we are better able to develop a manageable situation. Now, this is a difficult task. We can't instantly single source everything, because if we do, it could be catastrophic. But we need to begin to trend towards that direction, carefully, part by part, vendor by vendor at a time, so that we can obtain a more manageable situation and have a better chance of ensuring the right part in the right place at the right time. One of the advantages of the trend towards single sourcing allows us to put more business within one supplier's responsibility, thereby increasing our leverage with that supplier. Also, we are beginning to find that more and more suppliers are tuning up to the concept of just-in-time, and in fact, because other companies are also requesting just-in-time service from them, they are going to be better able to provide that for the smaller companies as well. Sometimes people say, I can't implement just-in-time with my company because I don't have enough leverage with my vendors. It turns out that the beginning steps of just-in-time involve cleaning up your own factory first, doing just-in-time within your own 4 walls, and then linking back to the suppliers.
Beginning within their own 4 walls was just the course pursued by Hewlett-Packard Greeley Division. Their JIT pilot project was a 3.5-inch disk drive production line, codenamed Sparrow. They reorganized their work area and process flow into a U-shaped pull system line.
Here is the current Sparrow production line, which is our 3.5-inch floppy disk drive line. What you see in this assembly process is the PC board load. This previously was separated out into a separate PC board process. We've now physically broken this process out and connected it all together into one continuous flow process. On this side is the test of the PC boards. As we move down from the PC board test, this is the final assembly area for the Sparrow production line. These products are pulled 1 unit at a time from station to station. Down here is the final assembly test, and then it's packaged and is ready to go to the customer.
Tektronix Vancouver also began a pilot project.
This is the APAS line. APAS stands for Advanced Probe Assembly System. The line is a combination of product and process design to enhance manufacturability, maintain the lowest possible amount of labor content, and have the highest possible quality level of output. The line is broken down into a number of workstations. Each workstation hands 1 unit at a time to the next operation. The cycle time is 6% of what it used to be. We measure the throughput in terms of minutes now compared to days as we did a year ago. The product moves from station to station, 1 at a time. Each operator is responsible for their own work as well as the work of the person prior to them. The material is staged at the beginning of the line, at the beginning of every shift. So the material that we have on the floor is 1 day's worth of material at all times.
Getting started is crucial. Although it may appear difficult at first, here are some suggestions from other manufacturers who have gone through the process. 1. The commitment of top management is essential for a successful JIT implementation. 2. A task force must be created to spearhead departmental involvement in implementation. 3. Find people within your organization who will act as champions for the just-in-time cause. 4. Educate indirect and direct labor on just-in-time principles and changes. Before you begin, you must realize that the first obstacle you will have to overcome is the natural tendency to resist change.
Change is very dramatic because you're totally changing the way you think. Before, under the American batch system, we believed in certain key things like more is better. So we had more inventory and more space and more people and more suppliers. And then we found out, no, the answer is you should have less. And if you go to people and say, you know, the way you've been thinking that more is better, like more suppliers, it's a very difficult translation because it's a change in philosophy of thinking that less is better rather than more is better.
I feel that starting JIT is very, very simple. And it's basically a mindset. And once you relieve the mindset and get your people totally involved, there is no way that you can stop it. Once it starts, the benefits are mind-boggling.
It's necessary to have your general manager's commitment to do this because your cost structure changes. You're going to be spending more money on process engineering and more money on freight in, which is greatly or more than offset by the savings that you have on space and inventory and material handling and scheduling and expediting and allocations and back orders. We did start off with a task force of 4 people. It certainly would be recommended or advisable if you wanted to even make your task force larger than this, of all the key individuals who are going to be driving this change in your company. We had a task force of 4 people who started off. We had a lot of sub-task force who worked on individual problems.
Successful pilot programs involved, at least initially, materials, production, finance, quality, information systems, and manufacturing engineering. If the pilot program involves a new product, design engineering might also be involved, as well as marketing. Before it's over, every department in the company will become involved in just-in-time.
When we started several years ago into the just-in-time mode, we needed a couple of champions people who understood the process in order to be able to communicate that down with the people that we have in our production lines. And I think we found some champions that helped us in this process. A lot of people in just-in-time have a great difficulty getting started, mainly because they try to plan too much. The key, I believe, is that you get started. You start somewhere in a product line with one of these champions that you have, and that's basically what we did. A way to draw someone in and expand this in your operation is to take some managers from another area and include them in that pilot area so that they can then spread the word back to the new area. But it's important you get this champion and you start something and you experiment and you understand what's going on.
Each manager is accountable for the quality and the output of his group. We've arranged the group so that the managers act as facilitators, not as bosses or supervisors. And by that I mean that the manager is on the scene to help the people only. One of the guidelines we have in the group, and maybe we should call it a rule, is that managers are on the line with the people more than 50% of the time. The manager is there when the problems occur, and the problems are resolved on the line when it is necessary to resolve them.
Some of the key areas I think that have really been effective and helpful for us been in the area of our people. When you get into a just-in-time, people react differently. It's a real challenge for our first-level managers to know what their role is. In fact, their role changes from being somewhat of a autocratic dictator into a coach and a facilitator. Some managers have a great deal of difficulty with that. Some managers adapt to that very easily. And I think this is a key, and one of the things that as you get into just-in-time you need to work with and realize that your managers might have some problems with this. Our people on the lines also have possibly some problems in terms of how to adjust from how they were being measured before until how they're being measured now. We had a task force that helped us to try to smooth over that transition, and I think they did a very effective job of coming up with a performance evaluation program for us.
The people involvement goes on and on in this area. You need to get your people on your manufacturing floor more directly involved. Have them do the preventive maintenance so they have a feeling of responsibility for their machines, a feeling of responsibility for the quality of their work so that they're passing on good work to the next worker, and that we have no inspectors on the floor, that they feel responsible for improving the quality at the end of the day when they have their team meeting. All of these things are so critical, this feeling of involvement in changing from one system to the other.
We turn the whole company over to the people, let the people decide actually how to do the process, how to do the total just-in-time, how to do pull lines, how to do the whole gamut from start to finish through the shipping operation. All you see at CMT in every area was designed and built by the people that actually work on the product and on the lines.
They live with the problem.
But how do the people on the line feel about the change to just-in-time? And how do they react to the possibility of workforce reductions?
When you get into JIT, it's a long process. There's a lot of things to fix up, and it takes a while to fix them. And ultimately, there's going to be substantial savings in material handling and less rework, and all that means less effort going in, which probably does mean less jobs. But on the one hand, it's fortunate that that takes a little bit of time, and normally attrition can take care of that. What can happen is the orders can dry up like that, and that's a serious problem. And once again, it gets down to this issue. I don't know that we have a lot of choice. We've got to get better. We're not going to have any jobs, period, anyway.
One other aspect of just-in-time that you tend to see over a period of time is the pride that people show in their work. And I think it comes about because of the opportunity to be able to participate more in what's going on. I'm really proud of our people and the way that they've done their job, and I think they show it in both their pride of what they're doing and their pride in workmanship.
I like it. I think it's taken a lot of the stress out of my job. It's made the job a lot easier. It makes the learning curve a lot more expanded.
It has worked really smooth, and everyone has worked good together, and it has really come off good.
I think you get a much more effective control of what's going on.
We've experienced a minimum of 75% reduction in work in process.
I like just in time for the fact that we work better as a team.
To be effective at JIT, one has to be willing to live with change.
It enhances our ability to become more effective for our customers, providing them superior service, superior quality, and also lets us grow because the customers keep wanting to come back.
Just in time is no panacea. It's just a tool, but a powerful tool that will no longer allow us to remain on a plateau.
Now, I come from a farm in southeast Nebraska, and I don't intend to go back to that farm. I don't think I can. I'm obsolete. So there must be an answer to this. The answer is we need to start learning how to manufacture.
The big question facing American manufacturing today is, can it be done? Will our resistance to this foreign idea prevent us from accepting just-in-time before we have the opportunity to put it to its true test? Enterprising manufacturers have already shown us that just-in-time works better than the old way, that it warrants more than just a brief experiment. Just in time. It's an issue of survival.